Hi guys. Okay, so I'm standing here today in the IWSS, or the Institute for Water Security and Science, in the Interdisciplinary Hydrology Lab. I would just like to thank Prof. Hubbard for allowing us to use his lab for this particular demo. So essentially today I'm going to show you guys the method that we use to enumerate our E. coli in our water samples. So we'll from the field we'll bring back a water sample like this, which is, if you can see over there, it's 100 milliliters, and we will then proceed to open said bottle of water. This is a substrate that is selective towards E. coli by suppressing other microbes, rendering them unable to grow or interfere with our counts, and thus ensuring that the only microbes that will be able to utilize this carbon source are our target organisms, in this case E. coli. So after adding our substrate to our 100 moles of water, we will shake the sample until the substrate is completely dissolved. This might take a while, so bear with me here for a few minutes. Good. While we wait for that foam to just settle off a bit, I'm just going to show you guys. So after this, we're going to be pouring that sample into this, what's called a quanti tray. This quanti tray has 48 small wells that you can see down here, and then 48 large wells, and then one overflow well, in case, because you could also see at the start of the video, my sample was a little bit more than 100 milliliters. Usually in this case, you want your sample rather to be a bit more than 100 milliliters than be less than that, so that you have enough to actually fill up all the trays with water. And this is what we will be using to get an estimate of our E. coli by comparing the number of small and large wells that are fluorescent or positive for E. coli after the incubation period, with a most probable number table, which will convert that into a concentration for us that we will then use to establish our concentration of E. coli in our original sample, obviously per 100 milliliters. So let's look at this. Should wait a bit more. See, what you want to wait for here is just the foam to die off a bit, because if you pour that out, the foam will enter your wells, and then as the foam dissipates, you will have emptier wells. So you're just taking some time to have that essentially settle out a bit. I suppose it might be worth telling you guys, so you could also use different substrates and then select for different microbes. So we also did a study where we looked for enterococci. Then you would just have a different substrate, and your incubation period and temperatures might differ depending on what you use. But in this instance, we're just using a E. coli example. Okay, I think the foam has more or less, for the most part, dissipated enough, so at least for the demonstration. Usually in the labs, we would wait for it to dissipate completely. But just in the instance, for the sake of time here, I might pour it out now. Okay, so what we're doing now, we're opening our sampling bottle again, and then being careful not to get your hand inside or stick your fingers in the quanti tray. You're trying to open it using this little tab and bending it a little bit so that you can pour your sample in without touching inside, potentially contaminating your wells or your samples. As you can see, the foam has died off for the most part now. So now we will just pour our sample in there, again making sure not to touch the insides of the tray. There we have that. Now what you want to try and do, you can see there are these little bubbles in there that you just want to have settle out, so you can just tap it lightly to have them sort of flow to the surface, as you can see over there. You don't want any air pockets that take up the space of the wells. So you can also flick it lightly on the front to knock out any air bubbles that might be present in the wells, which it seems to be pretty good now. So now, if we can just come over here, now we're going to run the tray through this quantity tray sealer. As you can see, it has this little mask that will fits the tray that we will then slide our tray into, and then we will put it through our quantity tray sealer. And you can see here on the other side how the heat and the pressure from the sealer sort of presses the wells and seals up our tray. And this is what it looks like. So you can see all our wells are nicely filled with water. They don't have any air pockets, they're not empty, and we even have some in our overflow well over there. So now what you would typically do, you would take this tray and all the other ones, all the other samples you took, and you would take them and incubate them based on, again, depending on the microbe, but I think E. coli was 37 degrees for 24 hours. And then the following day you would count them. We'll now be cutting to a counting of the sample. Good. Okay guys, so this is essentially part 2. It might be cut together in the same video if I can figure out how to do that. So after incubation, when you take the samples out, the quantity trays out, this is what it essentially looks like. So that clear, the water has now turned a certain color, and this is due to the substrate that causes the, when the E. coli essentially eats the substrate, it will leave behind a molecule that will color the water this way, and then we'll put it in something similar to this, which is just a black block. So there's a UV light over here, and then it just keeps out the light, and then we will put our tray in there, and you will count how many large and small wells. So in this one, you can look in there, there should be 1 small and 1 large well. So this one wasn't positive for a lot of E. coli, but it did have a little, just a little bit. And then if you take, so you would then note that, you would write down 1 large well is positive, 1 small well is positive. Now moving on to a sample that is more turbid and probably has more E. coli in it. So here you can see a lot more of the small and large wells are positive. So you would note that number. Give me a second and I'll count them quickly. So the small wells are 5 and the large ones are 1, 2. So it's 32 large wells, including the overflow well, and then 5 small wells. So essentially now, once you have those numbers written down, you're going to take it to a computer program, or you can print out a hard copy of it, which is a most probable number table, which will now convert these number of large and small wells to a concentration of E. coli. Again, keep in mind that it's per 100 milliliters of the original sample. We will now cut so that I can just quickly show you how that process looks. Okay guys, so part 3, I've got a little demonstration here. So now you can see we're sitting at the PC. We would have all our values from our counts, and you would create file names and sample IDs and all of that. So for ours, I'm just going to call this AEM example 1. You would select ColiAlert. Here are some of the other tests that you could use. But we used the ColiAlert test, and we specifically looked at E. coli, not at coliforms. Then here you would simply enter your number of large wells, which was 1 for our first example. Number of small wells was 1, and then you can calculate that, and there you have your most probable number is 2 E. coli colony-forming units per 100 milliliters. And now you have your confidence limits, 95% confidence limits, the lower being 0.3 and the upper being 5.9. Usually you would round these because you can't have 0.3 of a microbe. You can then proceed to log the entry, which will then save it in the file that you've made. Just to give you the other example, I think as memory serves, we had 35 large and 5 small. So if you calculate that one, now you can see, so for that one, we had 66.3 colony forming units per 100 milliliters, and there again our lower confidence limit and our upper confidence limit. And then you would essentially just proceed to do this for all of our samples, and that's how you get our concentrations in the watershed. So guys, yeah, just as a last note here, I'd just like to thank Professor Hubbard and the Institute for Water Security and Science and the Interdisciplinary Hydrology Labs, with both of which he heads, for allowing us to use his equipment and his lab for this little demonstration. Hey guys, cheers.